Welcome to The Explainer. Today, we're going to break down this incredibly intricate web of life that sustains us all, our planet's ecosystems. From the smallest bacteria to the largest forest, literally everything is connected.
Okay, let's just dive right in with a question that really gets to the heart of how our world works. What's the connection between a forest, a coral reef, and the very air you're breathing right now? Well, the answer is ecosystems, and that's the interconnected web we're going to explore today. To really get that, we've got to start with the basics, right? The building blocks. So in this first section, we'll break down the fundamental components that make all of these environments and life itself possible. So what exactly is an ecosystem? It's not just a place. It's a dynamic community where all the living organisms, we're talking plants, animals, microbes, the whole deal, are in a constant dance with their non-living surroundings. And every single ecosystem is defined by these two types of factors. On one side, you've got the biotic, or the living parts, all the plants, animals, and fungi. And on the other, you've got the abiotic, the non-living things they absolutely depend on, like sunlight for energy, the water they drink, and the soil right under them. So we've got the basic parts, but how do they all work together? In our second section, let's look at the engine of life. These are the core processes that literally power our planet and create and sustain life within these systems. It all starts with the most fundamental energy-creating process on Earth. I mean, one that turns simple sunlight into fuel for almost all life. And the crazy thing is, this is happening all around us, all the time. Yeah, it's photosynthesis. It's basically nature's own solar-powered food factory. Plants capture sunlight, water, and CO2. Then their chlorophyll converts these simple ingredients into glucose, a sugar that feeds the plant, and, as a pretty vital byproduct for us, releases the oxygen we breathe. And for all of you who love the details, here's the elegant chemical reaction that makes it all happen. You take 6 molecules of carbon dioxide plus 6 molecules of water, you power it with light energy, and boom, you get 1 molecule of sugar and you release 6 molecules of oxygen. Simple as that. But what happens when things die? That's where the decomposers come in. You can think of them as the planet's essential cleanup and recycling crew. Fungi and bacteria break down all the dead stuff, returning crucial nutrients to the soil so new life can grow. They're the ones who close the loop. So with these building blocks and this powerful engine in place, life has just exploded into an incredible variety of environments. So in Section 3, let's explore this world of ecosystems and check out some of life's amazingly diverse homes around the globe. Broadly speaking, we can split them into 2 major categories. You've got terrestrial ecosystems, which are the land-based communities you see in forests, deserts, and grasslands, and then, of course, the aquatic ecosystems, the water-based ones found in oceans, lakes, and rivers. Now, what's really interesting is how we can break down that aquatic world even further. And the critical difference? It's just salt. Marine ecosystems like oceans have high salt content and are all connected globally. Freshwater ecosystems, on the other hand, have very low salt, and they're usually found in smaller, more isolated places like lakes and rivers. Okay, this is all fascinating stuff, but you might be thinking, why does this really matter to me in my daily life? I mean, what do these systems actually do for us? Well, that's what we're covering in Section 4. This is where it gets personal. And here's the crucial point. These systems are not separate from us. Our society, our economy, our actual survival is directly linked to how healthy and stable they are. They are working for us, constantly. I mean, healthy ecosystems provide services that are literally priceless. They purify our air and water, they regulate the climate, they pollinate the crops that feed us. Some people have tried to put a price tag on it, and the estimates are just wild. Over $125 trillion a year. They're basically the life support system for our entire global economy. But, and this is a big but, this perfectly balanced, interconnected system is now facing pressures like never before. So in our final section, we need to look at how this whole system is under stress from some very modern challenges. One of the biggest challenges starts with a natural process. The greenhouse effect is actually essential. It acts like a blanket, keeping our planet warm enough for life. The problem is, human activity has been adding an excess of these gases, thickening the blanket and trapping too much heat. It's dangerously amplifying the whole effect. This change in the atmosphere has a direct and really damaging effect on our planet's biggest ecosystem, the oceans. But how does a gas in the air actually change the chemistry of the sea?
Well, it's a pretty direct chain reaction. First, there's way too much CO2 in the air. Second, the ocean absorbs a massive amount of it, about a quarter of it. And third, that dissolved CO2 reacts with the seawater to form carbonic acid, which slowly but surely makes the entire ocean more acidic.
And the consequences of that chemical change are profound. It harms organisms like coral and shellfish that need to build shells. And when they're in trouble, the entire marine food web that depends on them starts to get disrupted, threatening the stability of these massive ecosystems. And finally, another critical threat is the measurable rise in sea levels. As the planet warms up, two things happen. Glaciers and ice sheets melt, which adds water to the oceans. And the water itself actually expands as it gets warmer. Both are direct consequences of our warming climate. Which brings us right back to where we started. Every part of an ecosystem is connected, from the non-living sunlight to the living coral reefs, and all the chemical reactions in between. And that interconnected web, it includes us. We're part of it. So the final question isn't just about what's happening. It's about what role we are going to choose to play in the very system we depend on.